All right, well, welcome to the fourth of the 10 free Naturalist Nights for this year. These happen every Wednesday and Thursday nights here in Carbondale on Wednesdays and Thursdays in Aspen at Hallam Lake at the Aspen Center for Environmental Studies. My name is Sarah Johnson, and I represent the Wilderness Workshop. And tonight, representing the Aspen Center for Environmental Studies is Jim Kravitz over here. And so later in the evening, if you have questions, he's the guy in the blue baseball cap. The Naturalist Night series has been going on for a number of years and is quite a community institution, and it's always such a wonderful thing to gather all of you together week after week, and sometimes there's new faces, so you're welcome to all of you, and to all of you who have been seeing week after week, it's nice to see you again. And tonight, the Naturalist Nights happens for free because of all these amazing sponsors. Maybe your company is on this screen, and maybe you know people who own some of these companies, and maybe you actually visit some of these companies and do business with them. And anytime you have an opportunity to thank these folks, please do so. It goes a long ways. And on the back table tonight, those treats are all from Bonfire Coffee, which is such a, they go out, Charlie Chaco's, he goes overboard with those cookies. I swear they're so good. And tonight, our featured sponsor happens to be the Craig Ward, who is a realtor with Aspen Snowmass Sotheby's International Realty. And so he's gone out of his way to make a sizable donation to make this, this series as positive and effective as it is. So as I mentioned, GrassRoots TV films these each week, either here or in Aspen, and they then are aired on the TV, on their TV station throughout the coming week or so. And then we also put the YouTube video of this on our websites so that you can watch it again or tell your friends to watch it again or send it to a teacher who maybe wants to watch it or whoever you want to share it with. I am going to pass around the clipboards, and as you've heard in the past, the clipboards, we do ask everybody to sign in. This helps us with our numbers to help us report to our sponsors to say thank you and help them know how effective or how much of a reach their sponsorship had. So please do sign those. Also, this year, if you are not familiar, we are doing offering continuing education certificates for educators and anybody who wants a certificate to say you were here for 1 or 2 or 10 presentations this year. So next to the piano, there's an extra long clipboard. And if you're an educator or interested in this, please do sign that, and then every week make sure to initial next to the week. Otherwise, I might not give you enough credits. So, also, just as a new announcement, in response to the last week of activity in our world, the Wilderness Workshop has created an opportunity for you to pay attention to what's going on at the Capitol. And on this table over here, I've printed out something called the Capitol Watch. And it's really not meant to be a piece of paper. It's meant, thank you for holding it up over there. It's meant to be an email, so you get this in your email. It's also a website. You can go find it. But just as a reminder and as an introduction to it, I printed it out tonight. And it's like talking points for exactly what to say to who and what those people's phone numbers are. And so please find that on our website and sign up for that specifically. And just keep participating. That's all I can say about that. All right, one more announcement before tonight. So next week, we hope you'll all come back. Lynn Wickersham will be coming up from the southwest part of the state, and she will be she has created a book, and she will be presenting on her book called The Second Colorado Breeding Bird Atlas Project. So it'll be another awesome opportunity to learn about birds. If you didn't get enough last week, which was fantastic, come back next week. There's always more to learn and from these amazing speakers. So without further ado, tonight we are graciously welcome Jeff Lukas from Boulder. He's at CU Boulder. And Jeff Lukas, I have had the pleasure to see him speak at climate talks in the past with some of my water work on my other hats that I wear. But it's great. We're so grateful he drove all the way over. So he is the research integration specialist with the Western Water Assessment, which is a NOAA-supported research program based at the University of Colorado Boulder. For the past 15 years, Jeff has worked closely with water managers and other decision makers in the Rocky Mountain West to help them understand and prepare for climate-related vulnerabilities. He was the lead author of the 2014 Climate Change in Colorado report, which I happen to be holding right here. And you can get this online. Which this report was for the Colorado Water Conservation Board, or the CWCB, summarizing the latest science on observed climate trends and future climate projections for our state. He has a Bachelor of Arts in Geography from the University of Colorado in Boulder and a Master's of Science in Forestry from the University of Montana. And he also has had experience not just with water in the liquid form, but also in the frozen form, and has done a bit with snowpack as well. So we're happy to have you here, and we'll switch over these slides and get rolling.
Well, thank you so much for taking time out of your evenings to be here tonight. And to Sarah for Wilderness Workshop, and Jim for ACES and the other sponsors. I'm really grateful for the opportunity to come out here. Two kind of disclaimers. One is, I realized that coming from Boulder to provide climate information to folks in the Roaring Fork Valley is a little like carrying coals to Newcastle. There is not much that I can say, or probably will say, that you haven't already heard or had the opportunity to read in reports, in some form been exposed to through the efforts, the collective efforts of ACES, Wilderness Workshop, the Aspen Global Change Institute, the City of Aspen, Pitkin County, Aspen Ski Co., and myriad other individuals and entities in the Roaring Fork Valley in western Colorado. So I think all I can hope to do is maybe either say the same words and facts in a different order that perhaps provides a different perspective or framing, maybe add here and there at least a few insights to help you connect things you've already heard about climate change and potential impacts to the particular resources that make the Roaring Fork Valley what it is. The other disclaimer is that I always get to the end of these as I put my slides together, and I'm like, wow, this is all about the problems and not much about the solutions. And unfortunately, that's kind of the realm that I work in. There are folks who do similar kind of work and bringing climate science to people who work more on the sort of the then what end, okay, and work more directly. You work on the policy side, or work on the implementation side if you're a resource manager, or work with publics more directly. And I tend to be kind of a bridge from the research community to resource managers and other decision makers, as Sarah said. And I tend to pretty much describe problems. And to the extent that I can provide guidance in how they might lay out and implement solutions, I do that, but I tend to be a problem person, so I apologize for that, because these end up being quite depressing by the end of them. It feels like a litany, so I'll put that out there first. So speaking of the things that have already been said about climate change and the Roaring Fork Valley, I commend to you this report, which was done by the Aspen Global Change Institute in 2014, an update of a 2006 report, I believe. It's available at their website. Really wonderful and rich document that speaks to a lot of the things I'm going to speak to, and goes a little further with their stakeholder interviews, views from the ground, and then guidance for resiliency planning. If you want to get deeper into the problem side, light reading, no. This report that Sarah already showed you, which is available at our website, which is www.colorado.edu. And so a lot of what I'll be laying out comes from this, and hopefully usefully tuned for this area and the particular resources and amenities and values of the Roaring Fork Valley. And I said I'd start with past climate. Past climate. Well, this is some really past climate. How many were here, I think it was 2 weeks ago, for the talk about the snowmastodon site, Ziegler Reservoir in Snowmass? Incredible. So what can we say from this besides that paleontology and paleoecology are really, really cool? Well, it gives us a notion that the Earth's climate and then the climate of the Roaring Fork Valley does not stay in one place for very long on geologic timescales. And if you nudge the Earth's climate system by changing the energy balance, in this case, the shape of the Earth's orbit and its inclination wobbling back and forth over long time scales, thousands of years, conspire to make the amount of solar radiation that comes into the northern hemisphere wax and wane. And it leads to this wonderful oscillation between glacial and interglacial climates, including the previous interglacial, where it was, we believe, a little warmer than today, higher tree line in the Roaring Fork Valley and Colorado than today. But here we are in today's climate. And so I wanted to start with kind of my outsider's perspective, as someone who's lived on the Front Range for over 30 years and always looking longingly at the western slope like all of us do. I'm sorry. And say, boy, wouldn't it be nice to live there? Because they're all, obligatory photo of the maroon bells. You cannot do a PowerPoint with scenic photography of the valley without that. We've got all these incredible amenities in the Roaring Fork Valley, and obviously the kind of the geophysical setting, the mountains have a lot to do with it, and I just want to kind of reinforce because I'm a climate guy, the importance of climate and sort of driving the diversity and the nature of these amenities and resources. And I think the word I used, I can't remember if I put this in the little blurb, it came out in my radio interview with Aspen Public Radio, what I called the charmed climate of the Roaring Fork Valley. Because I think it's really nice. It's a nice climate. These warm summer days and cool nights and cold, okay, maybe a little too snowy winter this year. Plentiful sunshine the last couple weeks notwithstanding. Moderate precipitation here on this end, obviously higher precipitation up valley. And then these steep elevational gradients, and you have sharp climatic gradients. You kind of choose your own adventure. If you want to be warmer and drier, you stay down here. If you want to be cooler and wetter, you move up valley and up slope. And we often hear that Colorado has a semi-arid climate, dry west. Well, mostly. Kind of the yellow, orange, and red parts are fairly dry. But then we've got these islands of moisture, these cooler, wetter islands of moisture. And it turns out the Elk Mountains, so in the lower part of that area, I've kind of circled the Roaring Fork Valley at large and the surrounding high terrain, and the Elk Mountains are the blue blob at the bottom of that circle. And it's one of the wettest islands of moisture in the state, over 50 inches of precipitation annually in the high Elks. And it's really the source of a lot of what we'll talk about today. So these deep, long-lasting snowpacks, and we'll find out how long-lasting this year. Abundant creeks and rivers. I mean, really, you come from the Front Range, and you come here, and you look at the size of the Roaring Fork Valley, and you look at the size of the Roaring Fork River, and you say, wow, it feels like an order of magnitude more water than compared to a similar sized watershed on the Front Range. I mean, you really are blessed with amazing creeks and rivers out here. Good that snow melts, and a lot of it runs off, and a lot of it stays in the soil, and so really good spring summer soil moisture. Diverse and lush vegetation and wildlife habitats. I know pinyon juniper maybe not so lush, but you've got that diversity from the PJ all the way up into the aspen and the spruce and the subalpine. And I don't know, for the same vegetation type, everything looks wetter to me when I'm in the Roaring Fork Valley. Just a lusher understory. Things just look a little greener here than other parts of the state. And ideal for various types of year-round recreation. There are some problems with this climate. It's not perfect. Especially this year, the snowstorms that cause hazards to life and limb and property, serious avalanche hazard further up in the Roaring Fork Valley. Periodically, you get snowmelt-driven flooding. And occasionally, you have severe drought impacts like in 2002 and 2012. But if you compare the Roaring Fork Valley with other parts of the state, particularly the Front Range, eastern Colorado, you've got a lower risk of severe drought. The precipitation from year to year is not as variable as east of the divide. Lower risk of windstorms, downslope windstorms. Lower risk of hail and tornadoes flash flooding. You don't get the type of thunderstorm development here in western Colorado generally that you can get on the Front Range. Lower risk of heat waves, and at least historically in this valley, wildfires, than compared to the Front Range and the rest of Colorado. Now, I think the Roaring Fork Valley has been lucky with respect to wildfire. I think many of you might have sensed that looking at big fires on the Front Range and the West Slope over the last 10 to 15 years. And also, I think a little bit with flash flooding as well. Even though the risk generally is lower, there are other parts of the West Slope that have seen big flash floods over the last 30 to 50 years, and I can't find anything like that here. So if we look at kind of the basic elements of climate, start with the precipitation. I'm sorry, I'm using Pitkin County because it's more representative of the Roaring Fork Valley. How many of you are on the Pitkin side of the people here? And I assume the rest of you are on the Garfield side. Anyone from another county here? County. All right, cool. Thanks for coming. So Pitkin County annual precipitation, the thing you notice is it goes up and down a lot. It's highly variable over a range of a little more than twofold, from a little under 20 inches to over 40 in the biggest. And this is kind of an area average, so represents sort of maybe a mid-elevation of 9 to 10,000 feet. And even though we kind of feel the last 15 years as pretty dry, I think we're really remembering those droughts. The early 2000s, and then 2012, 2013, and maybe colors these at least average to above average years we've had, because the average since 2000 is really about the same as the century before that, which surprised me actually when I looked at it. 1977 and a couple years in the 30s, even drier than those, what we think of as like the really severe drought years of the last 15 years. What we have to keep in mind, this is a critical element of how I will unfold the impacts of climate change, is to recognize that the atmosphere giveth and the atmosphere taketh most of it away before it reaches use by ecosystems and or by stream biota or human users of the water. So on average, in the Roaring Fork Valley, of the precipitation that falls, roughly 2/3 goes back up into the atmosphere before it reaches a stream or river. We call that blanket term evapotranspiration. So that's evaporation from soils and from open water. It's transpiration from plants and trees as they use that water in their processes, and also includes sublimation from the snowpack, where during the winter before melt, snow can go directly from solid to vapor form, goes back up. And evapotranspiration is driven in large part by temperature. So think about that for a bit. And we know from deep past that you nudge the climate system by changing the energy balance of the Earth, and the climate can shift dramatically, and it can shift quickly. And what we've been doing is emitting greenhouse gases into the atmosphere, largely CO2, also methane and chlorofluorocarbons and nitrous oxide. And collectively, they're at their highest levels in at least 800,000 years. We know that from ice cores from Antarctica, and probably in several million years. And we're giving the climate system a big nudge. We're retaining heat in the lower atmosphere. It's warming the surface. We expect that from long-standing physical theory, and we see it happening. And after this sort of false plateau in the about the 2000 to 2010 range, we see global surface temperatures, land and ocean, have reached record highs in 2014, 2015, 2016. We don't expect it to continue going at that rate past the way it has the last 3 years. And in fact, in all likelihood, 2017 will come out a little cooler than 2016, because the heating has gotten an extra push from the big El Nino event that we had that tapered off early last year, that tends to bring water from the ocean, which pulls in 90% of the excess heat from the greenhouse gas nudge to the climate system. During the El Nino, some of that was given back up to the atmosphere. We're going to a cooler Pacific right now. That's going to take some of that heat back in. So we'll probably keep going up at more like that rate. Do we see this being expressed? This is what's being expressed at a global scale. We are part of the globe. We're a very small part of it. And there's a lot of other processes and variability that go on at the scale of Colorado and the Roaring Fork Valley. But even so, we still see this same trend. We see that the last 15 years has been warmer than any such period in the last 100 years, and probably a lot longer than that, by about 1.5 degrees over the previous 30 years, and about 2 degrees warmer than the 20th century as a whole. 2012, the warmest year on record. 2015 was the third warmest, and 2016 has just come in. The latest numbers from NOAA at number 4. So the last 5 years have seen 3 of the hottest 5 years in Colorado's history. It's not out of the question that the next year could be a little cooler than average, but we should expect that even with the ups and downs, that trend will continue. The question is at what rate and for how long. And if we look a little more closely, this is a composited record for Pitkin County. We don't have single station records that are high enough quality and are of this length, so this has been composited from records within Pitkin County and outside of it to kind of give us a general representation, and it's showing very similar trends over time, and so about 2 degrees warmer since 2000 compared to the previous 30 years. So getting back to the evapotranspiration, when you warm the atmosphere, you are basically increasing the size of what I call the atmospheric sponge, the ability of the atmosphere to hold moisture. And that means that at any given time, all else being equal, that warmer atmosphere is able to pull more moisture out of the soils, the vegetation, the snowpack, and open water. So on average, you will tend to increase that fraction going up into the atmosphere, decrease runoff. And it's not just runoff, though that's a pretty important effect. There's an overall, I don't know what to call it besides a drying effect. Usually when we say drier, we're referring to precipitation. This is apart from precipitation. It doesn't have to change for a warmer atmosphere to have this effect, to have what I call this overall drying effect. When the atmosphere is warmer, you tend to have more rain and less snow. You tend to have reduced snowpacks, earlier peak runoff, reduced annual flows. This is kind of the litany here. Reduced groundwater recharge, reduced soil moisture. So you're tipping pretty much all of the parts of the water cycle. And then in the vegetation and landscape, similarly, greater plant moisture demand, lower forest productivity, especially these forests here, at least up into the subalpine, tend to be moisture limited rather than energy limited. More tree mortality, more insect infestations, more wildfire, shifts in plant and animal ranges. These changes all look a lot like drought, and so that's not a bad way to think of it. That the warming alone will tend to make the water cycle, the landscapes, droughtier. So for a given amount of precipitation, even in a really wet year like this, when you have a warmer atmosphere, and we'll find out this spring and summer if this really wet year is as effective as previous wet years like 1997, 1983, 1984, and 1957. I suspect not, because we'll kind of, once the atmospheric rivers stop dumping moisture our way and California goes back into its summer dry season and we dry out here in June, I think we'll kind of pop up back above average for spring, summer temperatures, and we'll find we're not going to get as much bang for our buck as in those really wet years several decades ago. So as we all know, Roaring Fork Basin, this is true all over Colorado. We've got a snowmelt-driven hydrology. So we've got, in the purple, we've got the snowpack that builds over the winter months. In this year, kind of a crazy curve where it started out very low, and then December, January have been almost vertical, going up, stopping who knows where. It will come to a peak, I swear. I can tell you this as a scientist. It will not start an ice age this year. It will melt out. It will come back down and melt out fully in June and July. And as the melt occurs, it drives the runoff, which goes just as steeply up to a peak generally around here in June, and then tapers off very quickly as that pulse of snowmelt goes downstream. So very important thing to do when you're looking at the impacts, the potential impacts of this warming on the water cycle, is look at the snowpack. And when you look at the snowpack, so here I'm looking at the Schofield Pass snowtail, which is actually on the Gunnison side, don't tell anyone, but it's basically on the back side of the Maroon Bells, 10,700 feet. It is one of the snowiest sites in Colorado. The snowiest is up near Steamboat Springs. They get about 50 inches of precipitation annually, the vast majority of which accumulates as snowpack. And so the purple bars are the peak snowpack or peak snow water equivalent, the amount of liquid water embedded in the snowpack. Over the last 30 years that site has been operating, and then the curves above it in purple, the date of that peak SWE, and then going from April to July. So when things are later, they'll be higher up on that graph, and then the melt-out date in brown. And we can see they're all tipping, as we would expect, in the same direction. And the question is that tilt towards lower peak snowpack, earlier date of peak snowpack, and earlier melt-out, is that being influenced by the warming? We would expect it to be so, but we also had wetter conditions, more annual precipitation, we know this, in the 1980s and 1990s. And when you have less precipitation, you have less snowpack accumulating, and a smaller snowpack tends to peak and melt out and run off sooner. So this is part of our natural variability, or really noise in the system, if we're trying to discern a signal from warming. So it is hard to tell from this and other sites in this area, when researchers have aggregated sites across Colorado, there is a clearer signal of a temperature effect. It is not that big yet, but it does seem to be pushing things downward. We're getting less snowpack accumulating for the same annual precipitation, and it is coming off a little sooner than previously. What do we see? Then after the snowpack, we look downstream. Okay, what are we getting in our streams and rivers? And if you look at the Roaring Fork at Glenwood Springs, so the aggregate runoff of the whole Roaring Fork Valley, we see, again, enormous variability, and really more closer to fourfold variability versus twofold for precipitation. And that gives you a hint as to that impact of evapotranspiration. That evapotranspiration is sort of, it's accentuating the variability in precipitation because it's taking this big tax, and you tend to get proportionally more evapotranspiration, more of that loss to the atmosphere in the drier years. So it tends to make the dry years have even less runoff, and then the reverse in a year like this year, we hope, that we'll actually get a bigger peak than you would expect from the percentage of precipitation over normal. If you look at the last 16 years or so, we see it's been a little lower than the previous 50. Is that the influence of temperature? I'd need to look at more records. This one also is not corrected for the diversions that occur. They're sent transbasin through the Fry Arc project and the Twin Lakes project. It's hard to tell. Again, with this variability in the system, it's hard to tell the impacts. Looking at these average conditions, over this period where we've experienced much warmer temperatures. What we do know, though, is that human systems and natural systems, ecosystems, tend to bend and break during the extreme years. They care, in many cases, less about averages and trends and more about a big extreme event or year. And this was, dry up in the Crystal River in summer of 2012, one of those severe drought years. So what have we seen in western Colorado and the Roaring Fork in the last few decades? We have to summarize. We've seen this strong warming in all seasons that clearly seems different than the variability in temperatures of the previous century and is very plausibly connected with the larger global warming, which is strongly connected with these human-made greenhouse gases. Precipitation, highly variable. We know that from the last 100 years of record. We know it from even longer tree ring records. Highly variable, not much recent trends. The drought years of 2002, 2012, in terms of precipitation, are not out of line with previous drought years. So I don't think precipitation is being impacted by larger human-caused changes to the climate system. But in the water cycle, we would expect those warmer temperatures to be pushing things around, pushing things earlier, pushing things lower. They are moving in that direction. It's hard to tell exactly how much of that is due to the warming, but it's, again, very plausible. And then we've had these extremes, severe drought impacts in 2002 and 2012, certainly much increased wildfire occurrence in Colorado and the Rocky Mountain region. It just has not manifested here in the Roaring Fork Valley. Again, plausibly connected with the warming. No trends in extreme precipitation events. So overall, warming, which has a human-caused component, is having some effects already, but modest compared to the likely future impacts. So, yeah, question?
In Boulder, we had that extreme precipitation event, and isn't this a narrow study? This particular study that's just looking at western?
Oh, yeah. So when I say no trends in extreme precipitation events, that's actually from a statewide perspective. And I have tried to integrate what happened in Boulder, which I know very well, put out an assessment of that event right after it happened in September 2013. Record 24-hour precipitation in Boulder, record 1 week precipitation in Boulder, hugely destructive flooding. It's still, even with that event, it still doesn't push a long-term trend that's statistically significant. Again, we've got a lot of variability and noise in the system. Now, if you ask me, was that event influenced by human-caused climate change? I would say that's very plausible. So thinking about that atmospheric sponge, it gets bigger when it's warmer. It can pull more moisture out of the surface. When it is wrung out, when you have the right weather pattern that brings a lot of moisture in from the Pacific or the Gulf, or in this case, both, and is basically kind of almost perfectly designed to wring that moisture out, that sponge is bigger. It holds more moisture. How much more? Is it 5%, 10%? Possibly. The main cause of that event was a rare weather pattern. We have seen those rare weather patterns in the past in Colorado. We will see them again. When they recur, they will be able to tap a potentially larger moisture source because of the warmer climate and atmosphere. All right, so how do we get this picture, however depressing, of the future? We can use sort of just basic physical theory and make some back-of-the-envelope calculations. We could extrapolate current trends. Those are done as well, but we have also these very sophisticated tools, the global climate models, that give us what I call plausible climate futures. Based on our collective physical understanding of the climate system, all the components and processes in the system, and then they try to replicate the world in 3 dimensions, multi-layered atmosphere and oceans, with all of these processes and the transfer of moisture and energy and momentum according to basic physical laws between the little grid boxes to replicate as much as we can the Earth's climate. As we try to simulate historical climate and then work the system forward using different assumptions about our future greenhouse gas emissions and other human-caused changes, like land use changes, that might affect the climate system. And so when you run these simulations for Colorado, you see the same picture that you see elsewhere around the Earth, the details just varying with the amount of warming, because the interior of the continents at mid-latitudes, like we are, will warm more, about double the globe as a whole. Not as much as the Arctic, but more than the globe as a whole. But what you notice when you run a lot of these climate models, and several dozen have been developed by research institutions, universities, national academies, and centers around the world, they all have a slightly different take on how the pieces work together. I think that's good because no one has exactly the right answer. The climate system is an enormously complicated thing to try to model, to try to simulate and get right. And we don't know what the right answer is for how things will operate in the future. So these models have different operating assumptions about how the pieces fit together. In particular, how the clouds and water vapor will act as a feedback on the initial nudge from the greenhouse gases. That's known very well. So for a given emissions scenario, and I'm showing 2 that are widely used, RCP 8.5, which really is a worst case scenario. And I was actually heartened to hear that there's some debate among climate scientists about whether it is that plausible, given the trends that we've seen in the last 20 years. If we really have enough coal that could feasibly be burned, even with a rapidly growing global population, to give us that emissions scenario. So we hear of it sometimes as business as usual. There are multiple business as usual, that is, no carbon mitigation policies, multiple business as usual scenarios. This is kind of a high-end one. So this is almost, we do nothing and we kind of reverse course in terms of the carbon efficiency of the economy. RCP 4.5 assumes some pretty substantial progress in mitigating carbon emissions. It means global policies are enacted, or there's a massive change in technology, or both, that emissions peak on an annual basis in mid-century and then start coming down, whereas they keep going up in RCP 8.5. And the response in the climate system is readily apparent. You know, they kind of track together and then diverge after about 2040. All right, so a lot of the spread in this graph, you know, at this low end, we have a climate that's a little warmer than the last couple years, which you may not have noticed, but we're 2 degrees warmer than the 20th century mean. And so this would be a little warmer than that. So not a whole lot different than today. Up to 9 degrees warmer, so 7 degrees warmer than this past year. That's a huge change. Part of that difference is the assumptions of the emission scenarios. But then this spread, the spread of the blue lines, the spread of the red lines, is because of the differences between the models. Our fundamental uncertainty about how the climate system responds to a given nudge from emissions. And so we have to keep that in mind, that there are multiple plausible futures, and we don't know which one, even with a given emission scenario, is going to unfold. And so we have to think about multiple possibilities. We can hope for the low end, but prepare for something on the high end. Yeah, question?
Do these models take into account the more rapid melting of the ice sheets that I had the sense hadn't been anticipated and could accelerate all of this?
So do you mean there are feedbacks from the Well, I guess there are feedbacks from both the loss of Arctic sea ice and the loss of ice, particularly from the Greenland ice sheet, as it changes circulation and sea surface temperatures in the North Atlantic. That is a really good question, and the answer should be yes. Are they being updated fast enough to account for the most recent observations? These models do have what we call a cryosphere. They do have ice sheets, they do have sea ice, and so they know how those are supposed to interact based on our past observations. Have the models been updated enough to incorporate the latest observations of melt? I don't know that. But it's in the model. The ice sheets, sea ice are in the models. Whether enough, I don't know. All right, so in any case, warming is a given. Beyond the envelope of the historic climate, we don't know is how much beyond. What we do know is that when warming occurs, it's going to tend to shift things, with our wonderful diverse topography, we'll tend to shift things up valley and up slope. And so the same climate, today's climate, will kind of migrate. And we would expect that plants and animals, if they can, will want to migrate with it, especially the ones that are already at the lower end of their tolerance to temperatures. So to give you just a very crude sense of what, say, a 6 to 7 degree warming, which would be either at the high end of the low emission scenario or kind of the mid-range of the high emission scenario, that takes current Glenwood Springs temperatures, particularly in the warm season, and shifts them into Aspen. So Aspen would then have Glenwood Springs' current climate. Grand Junction temperatures move to Glenwood Springs. Carbondale is somewhere in the middle. Maybe 4 degrees takes Carbondale to Aspen. So we're talking big shifts in the climate, up valley, up slope. And then again, we're making that atmospheric sponge yet bigger. What is now a hard to discern effect of that increasing atmospheric sponge will get a lot clearer in 20, 30, 40 years, especially if we stay on a higher warming track, either because of high emissions or a high climate sensitivity relative to the potential climate sensitivities. Okay, so what about precipitation? And here we kind of have to throw up our hands. The models do not agree. We've got two general effects going on in Colorado. One is that storm tracks, as we know, they're very important as to whether you have a wet winter or a dry winter, and a wet year or dry year. They will tend to shift northward. We see some evidence of that already, and that's going to affect Arizona, New Mexico, northern Mexico first. We're kind of, at least in the 21st century, on the edge of where we expect that impact to be. But every given storm system moving along these storm tracks will tend to have more moisture because of that warmer atmosphere. So these two effects kind of compete, and they sort of come out in the wash. Some of the climate models say somewhat more precipitation for Colorado over the coming decades. Some say somewhat less, and some say much the same. We expect that high variability from year to year to continue, with, I'd say, majority of the climate models suggesting variability will increase. So maybe a more variable climate, even if annual precipitation stays close to what it is today. So given this certainty in more warming with the amount unknown and this uncertainty about precipitation, the warming will probably win with respect to the snowpack. And nearly all model projections, we take climate model output, run them through a hydrology model to simulate specifically the snowpack in the Roaring Fork Valley and western Colorado, we see the snowpack getting smaller. And I've tried to basically synthesize a few studies and show like a typical curve where we might end up, let's say 10 to 30% lower peak in 50 plus years. But we're really going to feel it in the early season, because more of that early season snow will fall as rain, and then in the late season that spring melt will happen sooner. Those late season snows will also be rain. And so we'll see a snowpack that is being eroded at both ends and also from the bottom up. where the snowpacks are lower down and thinner, closer to the freeze line in the spring and fall. So if you imagine this in 3 or even 4 dimensions, this sort of cap that we have on our mountains, which is thicker at the top and then it thins as we get down to the valley floor, will start eroding both in space, going up valley, up slope, and in time over the season, and in time over the 21st century if we continue to warm the climate. So what will that do to stream flow? And here I am showing something that 10 years ago would have been remarkable, and unfortunately it's kind of cutting out at the bottom. So this is a shot of a graphic that appeared in a report produced for the state of Colorado in 2012, the Colorado River Water Supply Availability Study. And it looked explicitly at different scenarios of climate change for 2040 and 2070 as it might affect many different dozens of watersheds in western Colorado. And so this is the Roaring Fork at Glenwood Springs, and showing that it's looking at 5 projections from 5 climate models that were specifically chosen to kind of represent both the uncertainty in future emission scenario and then the uncertainty about how sensitive the climate will be to those emissions. And what you end up with is in 4 of them, you end up with less runoff volume on an annual basis, so lower stream flows in aggregate over the course of the year, on average around 2070. In one scenario, that purple one, there's a boost in annual precipitation. So the model is a little more optimistic about future precipitation for Colorado, and that counterbalances the effect of warming, and you end up with more runoff by about 10%. So here we can say, and we see more studies with more models show a very similar thing, that the large majority of climate futures result in less runoff on an annual basis. Some result in more, but all of them show a shift towards earlier runoff. And for most uses, that the shift in the peak is not the important part. It's that red arrow, that as you shift that peak earlier, that late summer drop off to down base flows, where you tend to put the most stress on your late season irrigation and on your stream ecosystems. That's going to happen earlier and hit harder. So late summer flows decline 30 to 50% in all of the scenarios, even the one that gives you more runoff on an annual basis. This is, it's shifted. They're using a different annualization starting in October through September instead of January to December. Same peak in the black historical flows in June. This is from Maroon Creek, and this is for a study that was done for the city of Aspen just this past year in 2016. Again, 2070, using those same 5 climate model scenarios, and the wet one now in this particular watershed just gives you a little bump in annual flow, and the driest one gives you about minus 20%. All of them, the peak shifts earlier. All of them, those late summer flows decline a lot. So again, this is sort of an average representing typical conditions in 2070 under these different climate scenarios. What happens when a 2012 type year with about 60% of normal precipitation occurs in a much warmer climate? Then you have much worse impacts. So it's important to look at the averages. It's also really important to ask for the particular resource, amenity, species, infrastructure component at risk. What is it most vulnerable to? Is it an average? Is it a particular part of the seasonal runoff curve? Is it a really dry year? And then ask, okay, what happens if this occurs under a warmer climate? And these changes to water will touch nearly everything. I was trying to summarize this in words. I would just show pictures. And I could show someone, here's a trout. We can show someone fishing. We can show skiing. We can show, pretty much every activity. We could show almost every species in the Roaring Fork Valley, including ourselves, that depend on water in its, vapor, liquid, and solid forms. And so those changes in seasonality, changes in amount, changes in phase, falling as rain instead of snow, are going to touch just about everything in the valley. Will they be kind of a gentle slap, or will they be a fist pounding? That's going to depend on how much warming occurs by what time in the future. If we don't get emissions under control in the 21st century, all the bad things will happen eventually, even if the climate has a lower sensitivity, is on the lower end of the sensitivity range. It'll just take longer time to get there. I wanted to call out a few other things, and there was an excellent report I just saw put out by ACES with Aspen Global Change Institute talking about risks to the forests of the Roaring Fork Valley and forest loss as we have that shift of climates and then ecosystems wanting to move up slope. I'm going to talk here about specific disturbances also covered in that report, different pests, insects, and diseases. As you warm the climate, that warming-induced drying is stressing those trees more. They are less able to resist insect and pest invasion. We've certainly seen evidence of that across Colorado and the Rocky Mountain West in the last 15 or 20 years. We, in the future, are likely to see more frequent infestations and higher mortality from drought stress alone. That will be, obviously trees don't pick up and move, so the way that our forest zones, we have these nice elevational zones, the way that they shift is by establishment at the upper end and then mortality at the lower end of their elevational ranges. We've seen some of that across the West. We expect to see more of that in the future. And then as you have a warmer climate, you tend to dry out your fuels, make for easier ignition and faster fire spread. And we've seen evidence of that or manifestation of that in other parts of Colorado in the West, not so much right here. The studies that have looked specifically at the precursors to wildfire in the future climate projections are saying expect large increases in wildfire area burned in Colorado by mid-century, and we should expect even more by late century if that warming trend continues. I know we're getting deep into the litany here. Other weather and climate hazards, and I think this will be about it. So heavy precipitation, extreme precipitation in the case of events like the Front Range flooding in September 2013. Again, in a warmer climate, we would expect the atmospheric sponge gets bigger when you have the right weather pattern that really wrings out, that brings in the moisture into that sponge and then wrings it out abruptly. We expect that the biggest events are likely to get somewhat bigger. Not double in size, but 5, 10, 15, 20% bigger, which is not trivial. I mean, what creates these extreme events is a weather pattern, but a warmer atmosphere will not help. Again, the Roaring Fork Valley has not seen destructive flash flooding events, so liquid precipitation, in the last 30 to 50 years. We know from other parts of the West Slope that you can get much bigger events than what's been seen in the Roaring Fork Valley. So just basically natural variability asserting itself could create problems here even without considering climate change. Heat waves, which is a funny thing to talk about in Colorado, but if you think about shifting the temperature curve over in time, the distribution from the very hottest temperatures in one tail to the coolest, you're shifting them all when you shift to a warmer climate. And if you imagine a line at some threshold like 95 degrees, you can radically increase the number of events over that, or hot days over that threshold. So we should expect to see in the lower part of the Roaring Fork Valley that hot days over 95 Fahrenheit will go from rare to very rare to quite a bit more common in a 4, 5, 6 degree warmer climate. Though we really don't expect the human health impacts because those nights are still going to be cool enough to take the edge off that hot weather. But again, Glenwood will feel more like Grand Junction in a 6 degree warmer climate too, and that includes those even 100 degree days that they enjoy in Grand Junction now, or not. Winter storms, again, as I said, each individual storm will tend to be a little juicier in the future in a warmer climate. There won't necessarily be more of them, but the ones that do occur, like what we've experienced in the last several weeks, will be a little bigger on average. And then avalanches. The interviewer from Aspen Public Radio asked me, if avalanches are expected to get worse, and she thought she had heard some information to that effect, particularly with rain falling in the spring on snowpacks, potentially triggering wet snow avalanches. And I tried to look at the literature, and it wasn't very convincing for our particular climate, which is still pretty cold and dry through most of winter. I'm sorry, not dry in terms of the snowpack is not a wet snowpack like they have in the Cascades or the Sierra. Potentially an increase in those spring wet snow avalanches, but not sure in midwinter. Question?
But one of the things that causes kind of freak avalanches is weather variability. So you have a big, we have glazed ice in front of our house right now with snow on top of it. And the reason is very snowy day, warm weather, snow melts, we have glare ice right now in our driveway, and the reason is this weather pattern, which is grease lightning for avalanches. Snows, gets warm in the day, snow melts, and it becomes crust or ice at night because it freezes. You get more snow on top of that, and it's an ice skating rink with snow on it.
Yeah, no.
So it goes down, and you don't need much of a slope.
No, it could be an excellent slide layer to have glaze ice on top of the snow when more snow falls on it. Definitely deserves more study, especially in a place that already has substantial avalanche hazard. So how do we sum this up for our charmed climate currently in the Roaring Fork Valley? I think overall, things will get warmer, drier earlier, and many of the charms will be diminished. I don't think they'll go away entirely, even under a high warming scenario, but they'll be diminished. The lower elevations will experience more drying proportionately because we have a drier climate here in the valley bottom than in the mountains. It's also, is less cloudy, and so it's going to be impacted more by a warmer climate. Drought years, again, will hit harder than they do now, and the luck could run out with wildfires and floods, which could happen anyway, even without climate change. Climate change will tend to load the dice for those events. Okay, here's the hopeful solution part. We can shape the outcomes. And we can do that in a couple different ways. We can ameliorate the impacts that are either unavoidable or will happen by the way because we can't get on top of the emissions fast enough. And what I have seen over the last 10, 15 years of working in this realm is a tremendous amount of progress, people taking ownership of the problem, local and state governments and other entities, nonprofits, individuals, companies, with broad public support, at least in our neck of the woods, taking steps to assess vulnerabilities and plan for future impacts. That's the first step. Then promoting greater resilience in human systems and ecosystems, either with active management and investment or with helping leave things alone so that they have ecosystems and species have more resilience to the climate change impacts. And then reducing carbon emissions and future warming, both at the local scale and then advocating for broader changes in those. So I see all those things happening. I see them increasing. The current administration aside, I think they will keep going. There's a lot of momentum in Colorado and the Roaring Fork Valley. If you are involved in these, thank you. Thank you very much. And with that, I thank you for your kind attention.
Questions, but I will be bringing the microphone around, so start here. And speak really loud so everybody can hear you.
In Glenwood Springs this winter, we're having snow and then it's raining during the day and the snow is melting. I just finally noticed that it's beginning to pile up a little bit.
Yeah. So yes, the rain, these warm storms we've been getting, this is unusual. Even on the Front Range, we've been getting rain up to about 9,000 feet with some of these storms. And I would say for the most part, again, as with the Boulder floods, we're experiencing rare weather patterns. We've seen this before, where you get, if you're watching the weather in California, they call them atmospheric rivers. I would just call them, by the time it gets here, just a very warm and moist Pacific storm system. And so we see this in the past in western Colorado and on the Front Range, that you can get rain up to 9,000 feet. Does it happen very often? No, it does not. Do we expect it to happen more often in a warmer climate? Yes. Is this the new normal? No, not yet. In a high warming scenario, maybe this is what Glenwood Springs winters look like in 2100. But I think next year, or even the rest of the season, this active pattern with some very warm storms coming off the Pacific will snap back. We'll not see rain as much as we've had this year. This is kind of an outlier year. Again, we're kind of loading the dice. So maybe in the future, instead of this being an every 20 or 30 years, it's an every 10, and then an every 5, and then it becomes a new normal.
Historically, the data showed that, when it was warmer significantly between the ice ages, you showed early in the presentation, that it was wetter, moister. It looked like we were just looking more like a subtropic region. Like, what's different about this climate shift from shifting back that? I mean, it just seems like and I agree with your data and it makes sense, but it seems like it's so set on the current ecosystem of snowpack and accumulating, then running off. And it's like, it's going to be catastrophic for the current ecosystem and what it is, but why won't it shift back? Or are we watching it shift back to that more tropical just from what you showed earlier, it looked like it was when it was warmer.
Oh, yeah. So,
and I'm curious, what's different about the climate that we're headed towards to what was then, I guess is my question.
Yeah,
we're looking at 135,000.
Warmer, so in the previous interglacial, warmer being 2 to 3 degrees warmer. So basically, Snowmass was experiencing the climate that they would have in basalt now, maybe. So we're not talking like a huge biome shift. It's similar ecosystems to today, just shifted up in elevation, similar to what we would expect in a few to several decades, depending on our warming trajectory.
Misinterpreted the image.
Yeah, not tropical. Little higher tree line. It's actually fairly subtle in terms of
similar speciation and all.
Yeah, aside from the charismatic megafauna of the Pleistocene, but the vegetation. It would be I would burn coal in my car if we could bring the ground sloths back. No, I didn't say that. Do not broadcast that.
So we're within 150% of snowpack in places in Colorado, and we still have our heavy snow months left to go. And then there's the piece about earlier runoff in the spring. I think we're lining up for some floods this season.
Yeah, no, I'd say that under any condition of the last century, when you're sitting on 150% of normal in late January, even if we go average accumulation for the rest of the season, we'll still end up at maybe 130% of normal, which would portend a big runoff with the potential for flooding. Whether you get snowmelt flooding has a lot to do with whether it keeps being cloudy and cool, whether you continue to get little snowfalls well through May and into June. And then once you start, if you initiate the melt that late, it can go very quickly because the sun angle is high. When you snap out of the active storms, it heats up really quickly. More likely to have that in a warmer climate. Hard to say because maybe those later storms will tend to have more rain instead of snow. I agree that we're setting ourselves up for the potential for flooding this year. It's hard to kind of work out whether the kind of short, sharp, fast melt that we've seen in the past in like a 1983, 84, and even a 2010 June 2010, whether that's going to be more or less likely in a warming climate. I can make arguments kind of both ways.
I think we'll take one more question back here, and then.
Hey, thanks. I'm curious. Assuming you've been at this for a while, and I'm wondering if you've seen a shift in who's asking you and who's listening, and how it might sort of impact regulatory environment.
Yeah. So I see. I mainly, well, no, because I work across, with local, state, and federal entities, typically government entities in water resources and natural resource management, increasingly with municipalities across multiple sectors. And I say they've been interested in different climate risks, especially drought, for a very long time, especially water. Climate change coming to the forefront and having a place at the table among the big risks that they manage for, and thinking about future vulnerabilities. It's newer, but I'm seeing across almost all sectors, vastly increased awareness, vastly increased willingness to explicitly incorporate climate change into planning, and to entertain actions to ameliorate the effects of climate change. And so I have seen a lot of progress. I see that reflected in both who is asking us for information, in the water community particularly, and I see that reflected in the different vulnerability assessments and other planning documents that really call out climate change as a future risk. You see this at the municipal level, the county level, the state level. The state is really on board, and at least up until a few days ago, the federal agencies have really been pushing it during the previous administration, from the Bureau of Reclamation, which formerly was very hands-off of climate change. They have embraced it as a risk to their resources. National Park Service, U.S. Forest Service, even BLM. So I see across entities with climate-sensitive resources, amenities, infrastructure, and values, there is a lot of good acceptance of this problem and good work to get on top of it, or at least not to get steamrollered by it.
Awesome. Thanks, Jeff, so much. If you have other questions, I know he'll stick around. And have a wonderful evening.